Alright, so we're going to have a look at another question. Pick a new color. This one comes from the 2022 HSC Advanced Maths paper. This is question 28. We're going to do this in two separate videos. We're going to do part A and then come back and do part B in a separate one. So, or we'll do part C in a separate one. We'll do A and B in this one, then C in a separate one. So we're told the graph of the circle is shown. The interval connecting the origin and the point 11 makes an angle theta with the positive x-axis. By considering the value of theta, find the exact area of the shaded region as shown by the diagram. So in order for that line to connect the origin and the point 11, theta must be 45. So to begin with, we know theta has to be 45. It's a diagonal line. And so now we really just have a part of a circle like this, and then a linear section cut out of it. So we have the radius. We could change the angle of this drawing. We could keep it consistent with what the book has. We know that these lengths are both, they're not one, it's not a unit circle. Both of these are root 2. This is root 2. This is root 2. We know this is 45 degrees. And so we know how to find the area of a part of a circle where we know the radius and we know the angle. We also know how to find the area of a triangle. This triangle has base 1 and height 1. That's how it gets to the coordinate point 11. So the shaded area is going to be equal to the area of the wedge, which will be 45 over 360 times pi times the square root of 2 squared. This is just the area of a circle. It's an area of the part of a circle for a given angle. And then we're going to subtract from this 1/2 times 1 times 1, area of the triangle. So 45 on 360, this is 1/8. This is 1/8 times pi. 2 squared is 2 times 2, minus 1/2 times 1, that's minus 1/2. 2 times an eighth is 1/4, so this is pi on 4 minus 1/2. Now this is in fact the exact area of the shaded region, and this is the answer. So this is the shaded area. This is its exact form. This is what we're after. Now for part B, the question says, part of the hyperbola y is equal to a over b minus x all minus 1, which passes through the points 0, 0, 1, 1, 0, 0 and 1, 1, is drawn with the circle shown. Show that a is equal to b is equal to 2. Okay. So we need to show that this hyperbola passes through the points 0, 0, and we need to show that the hyperbola passes through the point 1, 1. So we have y equals a on b minus x minus 1. It passes through 0, 0, which implies that 0 is equal to a over b minus 1. Add 1 to both sides, multiply both sides by b. This tells us that a is equal to b. So immediately we know whatever one of them is, they are equal. We also know that they pass through the point 1, 1. So this was from the point 0, 0. Now from the point 1, 1, we find that 1 is equal to a over b minus 1 all minus 1. We can add 1 to both sides. This gives us 2 is equal to a over b minus 1. Multiply both sides by b minus 1. b minus 1. This gives us 2 times b minus 1 is equal to a. This tells us 2b minus 2 equals a, but we know a equals b. Right, we found this earlier, so we're going to let a equal b. This tells us 2b minus 2 equals b, minus b from both sides. Add 2 to both sides. This yields for us that b is equal to 2. Because b is equal to 2, b is equal to a, this means a is equal to 2. So we're able to show that b was equal to 2 and a was equal to 2 by using the points and the form of the function in question. So this is part A and B. There is a third part. We're going to do it in a separate video. We're going to go through the marking for these first two parts. So for part A, you need to find the area of the sector or some equivalent. The marker notes say specifically the area of the sector, so they'll really want up to about this point. And then the second mark, provide a correct solution. So this is what you had to do to get part A. We're fairly late in the paper. The marking in these later sections does tend to become a little bit more rigid. For part B, 1 mark if you can show that A is equal to B. So this is using the origin as a known point. And then you get the second mark for providing correct working to demonstrate that A is equal to 2 and B is equal to 2 as well. And this is using the fact that it passes through both the origin and the point 1,1. Combining those pieces of information yields you this solution. So this is how we did part A and B of question 28.